In our previous video, Introduction to Completing the Square, we reviewed how to complete the square if the coefficient of our squared term was just 1. In this video, we'll be considering what happens if our coefficient is greater than 1 or different from 1, and we'll be using both methods, method 1, where we work only on one side, and method 2, where we work on both sides. So let's take a look at two examples. Let's begin with 6x squared minus 48 equal to negative 12x. Now we'll use method 1 for this, where we work only on one side. And so I will bring this negative 12x on the left side, in which it'll be positive. So I'll write it as 6x squared plus 12x minus 48 equal to 0. So the 6x squared and the 48 stays just the same. We didn't do anything with those, but we did bring the negative 12x to the left, which makes it positive here. And so we write it in order from highest degree to smallest degree. Now we start by factoring out our a term, the coefficient of the square term. So we'll factor out 6, and we'll see how far we can take this. If I factor out 6, I can actually do so from all the terms, leaving me with x squared plus 2x, and we stop here, write our minus 48, and set that equal to 0. Now the reason why we do not need to factor the third term, even though we can factor the 6 from the entire expression, is because we only need the first two in order to complete the square, and then we will figure out the rest later. So let's complete this square. Now that it's factored, this is now what we divide by 2, not the 12. So to find out what perfect square we'll be working with, we're going to take this positive 2, divide it by 2, and that is just 1. So our perfect square is x plus 1 all squared, which when multiplied is x squared plus 2x plus 1. Now let's do that. Let's add in 1 to complete the square. So 6 times x squared plus 2x plus 1. But remember that we have to subtract 1 minus 48 equal 0. So I'll change these to red. So again, this is our perfect square, x squared plus 2x plus 1, but we cannot just add in 1, we then have to subtract 1 in order to balance the equation. Now this 1 is quite inconvenient, this negative 1. And so what we need to do is actually remove it from parentheses here so that we can write our perfect square normally. Keep in mind that this 6 is still operating on all the terms. Your original expression was x squared plus 12x, and so you still have that here. 6 times x squared is 6x. 6 times positive 2x is positive 12x. So you still have your original equation working. In this case, we are adding in not just 1, but 6 times 1 as well, which is 6. So if you keep that in mind, that we added in 6, then what we're subtracting in this example is also 6. Minus 6. So we will rewrite this as 6 times x squared plus 2x plus 1. We'll now close parentheses and write this as negative 48 minus 6 equal 0. Now again, this 6 is still operating on all the terms in parentheses. So this, though it's expressed as x squared plus 2x plus 1, which is the square we are completing, if we're going to remove it from parentheses, we have to remember that it is being multiplied by 6. So we added in 1 to complete this square, but if we're going to remove it from parentheses, then we need to subtract 6. So hopefully that makes sense. Now let's write this as a perfect square. 6 times x plus 1 all squared, and then we simplify negative 48 minus 6, which is negative 54. We remember to set this equal to 0, and so this is our final expression. Hey, if you haven't liked, shared, or subscribed yet, go do that now. Okay, bye. Now let's do another example where we are working with method 2. The example is 8x squared plus 16x equal 42. Now keep in mind that the method just depends on what you're most comfortable with, and you would just have to rewrite your equations based on what you're comfortable with. This is already perfectly set up so that we can work on both sides, and so we'll do that. We'll start again by factoring out the 8, which leaves us with x squared plus 2x, and this is equal to 42. Now just like we did before, this is also the perfect square we'll be working with. Because we have the first part, all we have to do is just add in 1 in order to complete the square. So we'll do that. So this is 8 times x squared plus 2x plus 1, and that completes that square. We set that equal to 42. But now let's establish what exactly we added in, because it's not as simple as just 1. Yes, it's just 1 to complete the square within the parentheses, but we have to figure out what we actually added to the equation itself. Remember, we started off with 8x squared plus 16x, which is what we have here. 8 times x squared, which is 8x squared, 8 times positive 2x, which is positive 16x. And so what we really added in was 8 times positive 1, which is 8. So then we have to also add 8 on the other side so that we maintain the equation. So we use the addition property of quality here. Now we can write it as our perfect square. So 8 times x plus 1 all squared is equal to 42 plus 8, which is 50. Hope this helps.